things like this crop up when we look at some more advanced problems. So this is what I gave you on Wednesday. So I want to go over this with y'all, and this is all we're going to do today. Okay, so one thing. When you have the inverse cosine expressed like that, that is not used as an exponent. This does not mean 1 over the cosine. Okay, which is one of the reasons why people argued about this, because, you know, you might think that, and that's wrong. Okay, this is why people write arc cosine. This is an inverse function. It's just another way to write inverse functions. That's why when we did the function notation, we wrote the little -1 there. That's just a symbol that implies inverse. It's not really being used as an exponent. So that is incorrect. That's a misconception. All right. And it's a typical misconception, by the way. Not everyone has that misconception, but it is common. So remember when we did this, when we had the sine and we took the sine of an angle, the output was a ratio, because for the triangle that had this radian and the hypotenuse is 1, that was the sine, right? If we do the inverse function, then we're going to get the output of the angle based upon the input of the ratio. So if you reversed, if you switch to the inverse, then this would be what we would have gotten. Now, there's also the issue of the principal values, which I won't elaborate right just now, but that's essentially what you're doing. So the inverse, if you switch it to the other side, would be the regular sine function of the angle will get you the ratio for the triangle that has that central angle. And if you switch that to the inverse, then the inverse of the ratio will give you the proper radian measurement. The only difference here is that we only want to output one result here. And with trigonometric functions, there's an infinite number of possible angles, because you can go around and around and around the circle anytime you want. So we restrict the output of the sine function to this location. And that's also true for the inverse, the reciprocal, which would be the cosecant. And it's also true for the tangent, because the tangent has sine on top. Whereas if we were dealing with the inverse of cosines, we would restrict the answer to the first and second quadrant. And this is going to be true for the cosines, the secants, and the cotangents, because the cotangent has cosine on top.